Hello everyone, we're going to start today by going over several AP practice problems. I like number 27 here. This is a no graphing calculator problem. So pause the video, give yourself 2 minutes. What's nice about this is what a topic that will be on your Chapter 5 test tomorrow. So pause the video, give yourself about 2 minutes, and then resume playing. All right, so if you need more time, just hit pause again. So remember the formula for average value is equal to 1 over b minus a times the integral from a to b of f of x dx. So with everything we're given in this problem, this becomes 1 over 0 minus a negative 4 times the integral from negative 4 to 0 of cosine of 1/2 x dx. So the fraction now becomes 1/4. And then as we go to take the antiderivative of cosine of 1/2 x, this is why I had you practice the integral of cosine of 2x dx and then the integral of 4 times sine of 2x dx. So as I take the antiderivative here, it is going to become sine of 1/2 x, but the derivative of this becomes cosine of 1/2 x times a half. So to get rid of that half, I need a 2 out in front as x goes from negative 4 to 0. So now we're going to end up with 1/4 times 2 times sine, this will just be half of 0, which is just 0, minus, then we'll get 2 times sine, half of negative 4 is negative 2. So this whole first part just goes to 0. So now I'm left with 1/4 times a negative 2, so we're going to get a negative 1/2 times sine of negative 2. And that's not one of the answers. We're close with A. There's no negative 2's in there, so what did they do? They used the fact that the sine function is odd. So if you recall, sine of negative x is equal to the opposite of sine x. So that's what's happening here. So this becomes negative 1/2 times the opposite of sine of 2. So then this becomes positive 1/2 times sine of 2. And that was E. Right, for this problem, it is a calculator okay problem, but go ahead and give this a try. Give yourself about 3 minutes. All right, so if you need more time, just pause the video again. So here the graph of f is shown in the figure above. If the integral from 1 to 3 of f of x dx is equal to 2.3, and capital F prime of x is equal to f of x, so the derivative of the antiderivative is just going to equal f of x, then we want to find capital F of 3 minus capital F of 0. So if you recall from the fundamental theorem of calculus part 2, that if capital F of x, or just capital F, is the antiderivative of f, then once we take that antiderivative, so we would have f of x as x goes from a to b, so this becomes f of b minus f of a. Well, the trick with this is that they're giving us this part. So we're going to go backwards and write it as that, or at least the integral that would give us that. So f of 3 minus f of 0 really comes from the integral of 0 to 3 of f of x dx. And then we can write this integral separated into the integral from 0 to 1 of f of x dx plus the integral from 1 to 3 of f of x dx. Because we already have this shaded region, now we just have to figure out from 0 to 1, that's going to be the area right here. And that's just a rectangle. So that becomes a 1 times 2. And then this was given to us here, so that's a 2.3. So 2 plus 2.3 gives us 4.3. So even though we were allowed to use a calculator on this one, we couldn't. There was no need for it, no way to do that. Okay, let's take a look at one more. Again, you can use your calculator on this. Now, I will give you a hint here. We have not done a problem quite like this, but you can use, if you go to a graphs page and you graph both of these, I'll walk you through what to do. So this one we'll actually just go through together. So go to a graphs page, make sure you're in radian mode, graph both y equals cosine x and y equals x. Then I want you guys to find a point of intersection. So go to Menu, 6, 4, and find the point of intersection of both of these graphs. So the point of intersection, the x value, is going to be about a 0.739. So now what we could do is if you go back to Menu, Analyze Graph, so 6, then if you go down to 8, at least it says 8 on my calculator, we want to see the option for bounded area. So go ahead and click on that. Now it's asking you for the lower bound. So you could just type in 0, because that would be the y-axis. And then the upper bound, type in the 0.739. And what it did, this is what we should see on our calculator. We should see the curve here of cosine x, and then we have our line y equals x. So we're looking at this shaded region from 0, so this is our 0.739. So we're looking for this area right here. And we should get a value of 0.400489. And that's giving us C would be the closest one to that. So definitely how to use our calculator for this. Now, even if we didn't use our graph to find the point of intersection, which is the easiest way to do this, we could have used the solve feature as well, but then there's a little bit more work tied into that. All right, so tomorrow, or after the test on Friday, is what we're actually going to be getting into, are other techniques of integration. And before we do that, though, one technique here is to use trig identities to help us. So that's what the integral of sine square x dx involves, the problem that I showed you yesterday, or had you try from yesterday. So let's list the 5 Pythagorean identities. So pause the video, write them all out without looking anything up. Okay, so if you're ready, let's go over these. If not, pause the video again. The easiest one to start with is sine square x plus cosine square x equals 1. Then the other two come from rearranging this. So sine square x is equal to 1 minus cosine square x. And cosine square x is equal to 1 minus sine square x. Our fourth one comes from, if you divide everything in this first equation, let's divide it by sine square x. So sine square x divided by sine square x is 1. Cosine square x over sine square x will give us cotangent square x. And then we get 1 over sine square x, which is cosecant square x. So there's our fourth one. Our fifth one is if we take this first one and divide everything by cosine square x. So sine square x over cosine square x is tangent square x. Cosine square x over cosine square x is 1, and 1 over cosine square x is secant square x. So very important to know these. Now let's take a look at, this is what you needed, the hint I gave you for yesterday's integral of sine square x dx. So let's write out the 3 versions of cosine 2x. So remember, that's equal to cosine square x minus sine square x. And that's really the only one you need here to memorize, because the other two come from using what was up here for the Pythagorean identities. So if I replace sine square x with 1 minus cosine square x, I get cosine square x. This will turn into a plus cosine square x, so I get a 2 cosine square x minus 1. So we'll kind of underline the equivalences to look at. Or if I replace cosine square x with 1 minus sine square x, we'll get 1 minus sine square x minus sine square x. So this becomes 1 minus 2 sine square x. So these are the three versions of the cosine 2x identity. All right, so let's take a look at how we can use that to help us out. The Pythagorean identities are not going to be helpful here straightforward or directly, because if I don't know how to take the derivative of sine square x, I don't know how to take the derivative of cosine square x. So rewriting it in terms of cosine square x is not going to help. What we can do, though, is take the cosine 2x and start with the 1 minus 2 sine square x. And I chose this one again because the other one that involves a sine square x also involves a cosine square x, and that's not going to help me. What I could do is solve this for sine square x. So let's just switch these around. So I could say 2 sine square x is going to equal 1 minus cosine of 2x. Then I could divide everything by 2. So sine square x is going to equal 1/2 minus 1/2 cosine of 2x. That's what I'm going to replace this with now. So now this becomes the integral of 1/2 minus 1/2 cosine of 2x dx. So now we'll go ahead and take the antiderivative here. So we're going to get a 1/2 x minus, we'll leave this 1/2 here. This is what we were practicing the other day. So the antiderivative of cosine 2x is really sine of 2x, but then we would need another 1/2 out in front, and then we would have plus c. So we get 1/2 x minus 1/4 sine of 2x plus c. So that's one way to do that. Or using another identity, we could say it's 1/2 x minus 1/4. If you recall, sine of 2x is equal to 2 sine x cosine x. So we could replace that. And it looks a little simpler now. So now we get 1/2 x minus 1/2 sine x cosine x plus c. All right, here are the answers to the two even problems from yesterday's assignment. Number 44 just had you looking at another slope field, so all you wanted to do is plot the point -1, -2, and just kind of follow the little tangent lines, the little line segments there, what the curve, sort of the guidelines for the curve. So I'm going to post a PDF with all of the problems worked out. Just let me know if you have any questions. All right, so here's the assignment. Please make sure you correct all the previous homework assignments. Now this free response question, it's just entitled the Chicago free response question number 6. So that's going to be posted as a separate PDF. Now all of this is due Friday. Your test is tomorrow. So some more AP practice problems, 4 more. And then please take the time to go through and figure out this integral of cosine square x dx. When you're done, then use your calculator to check.